We're gonna do an exploration of the mechanisms found on W20 T2 Part 4, 6F. This is the second 6F. There was a typo. What else we got going on here? We got an alpha beta unsaturated carbonyl. And we got a new bond from this position here, that position to the beta position of our species there. KOET, let's see. Let's try to break this thing down. There's the new bond. R prime must have been defined on some other location. We should try to get R prime. I'm believing this is R prime, but I'm going to verify that hopefully over here. I got Zoom stuff in the way now. This is the way it goes. R prime, where are you, R prime? So it's a sec. Yeah, you wrote a note. On the same one we were just doing, I wrote a note and I didn't even read my own note. Nice. Okay, thank you. Yeah, R prime is defined. Sec-butyl, which is this group that I suspected it was. Okay, good. Because I was having trouble seeing this at 1,4 addition myself. There's a new bond here. There's a new bond here. Okay. They're the same molecule. So, yeah. How do you get a bond from this position here? Well, you realize that's a very special hydrogen with a pKa of 10. We took advantage of that type of hydrogen in the malonic ester synthesis and the acetoacetic ester synthesis. This is just the same. We just don't have a malonic or acetoacetic ester. And you've generated a very nice, stable nucleophile that's also a good leaving group. That's the criteria for a 1,4 nucleophile. And here it is. Lone pair, minus charge, R prime, carbonyl. Here's your 1,4 addition. You can't shorten this, everybody. Please don't look for a shortcut. You attack, and you must show the resonance, because that's what the 1,4 is. If I don't see your arrows doing a 1,4 mechanism, the 1,4 is named after the mechanism, everybody. Don't try to short form it. It attacks position 1, and the electrons flow to 1, 2, 3, all the way up to 4. That's what 1,4 means. R prime, carbonyl, ring, carbonyl. New bond in purple to a carbon that's got an R prime on it. Carbon's got a single bond now to the ring with a double bond in the ring to an O minus. This is the enolate of the final product. Enolates are the conjugate bases of aldehydes or ketones, in this case, ketone. You got to pick up a proton on the alpha position. Conveniently, ethanol is present. I just copied it from the top of the screen. Acid base of enolates. You don't have to show me the enol and then tautomerize it. That would be a waste of your time. It's not wrong. Go straight to the alpha position by resonating and protonating. And you're finished with your 1,4 addition. And then I love following that with aldol that make another ring. It's kind of a Robinson annulation when you make the ring, but don't worry about names. Just tell me what has to happen to make this product here. I even tried to help you by doing a sigma rotation here and here. And I wanted you to see that this alpha position was needed to make this product. And this alpha position, the other alpha position, where are you, the other alpha position? Let's see. More substituted, tachycarbonyl. Oh, Oh. Let's see. That's an alpha position, right? Gonna make a ring there. This is another alpha position. Here's another alpha position. Which one's gonna get us that other ring? I don't know. Let's just do this top one and then we'll try to figure out the bottom. Because I saw this one instantly. Double bond between this carbon and this carbon. That's what aldol does. There's nothing about hindrance here. It's just analyzing which alpha H is going to give which product. There's no LDA or anything present, so hindrance is not an issue here. First step, you got to make your anion. And let's move everything. Oh, wow. Down a little bit. Here we go. We're going to have R prime attached to a carbonyl. That one doesn't change. Ring. CR prime. C ring. Carbonyl. Lone pair. Minus. There you go. This C is going to attack over here. You're going to pick up a proton in the next step from ethanol. So red first. Did we do any combinations yet? No, we did not. Attack, generate an O minus. Solvent has a proton. And we'll regenerate our catalyst too. Lone pair, grabs H from solvent. Here's your aldol reaction product number 1 coming up. It's gonna look like what's on the bottom of the screen. I'll try my best. Yep. It'd be where, yeah. OH here. And that. And is that right? Carbonyl here. I got the OH in the wrong spot. Nope. I gotta verify I'm doing this right. Carbonyl is right here, correct? And the OH is right here. I don't even know if I'm gonna make the product that's right below it anymore. I don't know yet. It's okay. We gotta dehydrate this thing clearly, right? That's an ARP. Aldol reaction product. Condensation follows in the presence of heat. And we have the heat. We have the alpha H. And there you have it. And which product is that? I don't even know. Is it the top one? I think it is the top one. It's exactly the top one. Yeah. I'm starting to doubt myself for some reason. I don't know. Now on this one here, this ring's the same. There's no new bond there, so I'm not thinking about using this alpha H. There's no bond here. I'm thinking about this bond, making a double bond to which of these two carbonyls? Well, this one didn't change. It's the one outside the ring that changed this time. Ah, that's the one. So this is going to make nice ring size 1, 2, 3. Is that right? 1, 2, 3, 4. It's not a nice ring size, is it? It's not that one. It's not good. It's this one. It's the same one we did before. That makes sense now. Carbonyl inside, ring size 5. I'm just going to circle that ring because, you know, sometimes you got to figure out. There's the ring size 5 with a ketone in it. Here's the ring size 5 with a ketone in it. Here's this carbon here. I'm going to put a little asterisk on it. It ends up doubly bonded. It's the alpha carbon doubly bonded to the carbon attached to the, yeah. So I'll put a little telephone pole here. Asterisks attacks telephone pole. There you go. Sounds like a news headline. Okay, so we got to generate our nucleophile first, just like the first example. Now that we've established which alpha H is the correct guy. And it's going to go down here. Purple in on the action. I hate when I rotate the molecule. But I just did, I'm sorry. Carbonyl minus. And here's where we gotta make sure have that ready to be attacked. Step 1, attack. Step 2, protonate using ethanol. Get an aldol reaction product number 2. I'd like to remind you that was ARP up there, and this is ACP. We're going to make our ARP before we make our ACP every time. Time to make ARP. Need an alcohol from HOET. Baby blue. Here comes ARP. Whoa, don't. I don't know about that. That did not end up on the O. I'm not happy. I would have lost a quarter point. There we go. I'm happy now. Copy what you see at the top of the screen. Well, right above this molecule anyway. Except put an alcohol on the telephone pole. Yeah. Oof. Try my best. And telephone pole has an OH and an R prime, doesn't it? Still have an alpha H to go here on the asterisk. And same story, finish it off with OET minus. ETO minus. ACP. ACP. This is ARP. Dehydration of a aldol reaction product makes aldol condensation product. And that'll be the end of that story. There it is. Clean up all this incidental stuff. And there you have it.